gas law we're talking about today is Charles' law. Now, Charles' law looks at the description of the relationship between temperature and volume. So, we can remember this by saying Charles brings the TV to the party. T for temperature, V for volume, Charles, because that's the name of the law. So when we're talking about Charles' law, we're assuming that two things are constant. Our moles of our gas and our pressure in this current ideal gas. And we can come up with an expression that uses this. In this case, they are directly related. We've got a volume divided by our temperature is going to equal a constant, which will then allow us to predict that for any ideal gas at a certain volume and a certain temperature, as long as our moles and pressure are changed, that by dividing them under our second conditions, our volume divided by temperature to the next condition. So Charles' law is V1 over T1 equals V2 over T2, dividing in this case. We're going to follow the same solving process as we did for Boyle's law to solve a word problem with Charles. So what we've got, an ideal gas, it begins at a volume of 1.5 liters at a temperature of 250 Kelvin. It says that the volume of the gas increases to 6 liters. What is the temperature of the gas? So step number one, as always, underlining our important information. An ideal gas begins at a volume of 1.5 liters. Even if it didn't tell us that volume was here, we would notice that liters is our unit, liters for volume. And a temperature of 250 Kelvin, we're told its temperature, but we also should BQ that K is for Kelvin, which is a unit for temperature. Alright, now the volume of the gas increases to 6 liters. This is our new volume. And this last part says, what is the temperature of the gas? So we want to find out what our new temperature is of the gas. As we get into step 2, that's going to be useful. We've now underlined our important information. Step number 2 is actually identify our givens and our unknowns. So we've got volume of 1.5 liters. V1 equals 1.5 liters. And a temperature of 250 Kelvin. So our T1 is 250 Kelvin. Now in our second set of conditions, it says that the volume of the gas increases. So we have a change occurring. It's going to be our second. Our V2 is 6 liters. And as we already identified, our unknown is temperature. So T2 is our question. So we've underlined important information. We've got our givens and our unknowns. Now we can see that we have a T and a V here. And we said that Charles was bringing the TV to the party. We're going to be using Charles' law. Charles' law is V1 over T1 is equal to V2 over T2. So, now that we know several different laws, we've got Boyle's and we've got Charles, we're going to have to use our variables to determine what law to use. In this case, it's Charles, and we're dividing volume and temperature. Alright, step number 4 is plug in our values with units. So, step by step, I've got V1. My V1 is 1.5 liters. My T1 is 250 Kelvin. My V2 is 6 liters. And my T2 is my unknown. So I will keep that as my variable, as T2 in my denominator. Alright, so last step is to solve. Now in this case, my unknown is my temperature, which is in my denominator. In order to get this isolated, we're going to have to first cross multiply. So what I'm going to do is I'm going to be multiplying 1.5 liters times T2. I'm just going to rewrite this below. So I've got 1.5 liters times my T2. And then I'm going to take 250 Kelvin times 6 liters. And that's going to be on my other side. Alright, so now we've got this fraction into a more linear looking equation. Last step is to isolate T2. So right now our temperature and our volume are being multiplied. So we need to divide. We're going to divide by 1.5 liters. And whatever we do on this side, we've got to do on the other, 1.5 liters. We kept our units here for a reason. We need to figure out what we have to cancel. Notice we have liters here and here. Anything divided by itself is 1, we can cancel. And we can also cancel out these liters. On this side, we've got 1.5 divided by 1.5, which is going to leave me with T2. And now on this side, we have 250 Kelvin times the 6 divided by 1.5. Notice the only units left over is K. We know K is Kelvin, which is the temperature. So we're looking good so far. We can take this and plug it in. We've got 250 times 6 divided by 1.5. And we end up with 1,000. Now it's not just 1,000. We still have Kelvin here. So 1,000 Kelvin is our temperature too. And this would be our final answer. But let's double check and make sure that this makes sense. We had an initial volume of 1.5 liters. Our volume then increased to 6 liters. We said that Charles' law is a direct relationship. If one goes up, the other is going up. So we increased our volume, which means that our temperature should increase. And as we notice, we have 250 increases to 1,000. Both are increasing, so it checks out, and we have our units in our answer.